Distributed systems fail when the database update and the message broadcast are not bound by a single atomic transaction. If the database commit succeeds, but the message broker is unreachable, your downstream services never receive the necessary state change notification. The dual write problem arises when an application attempts to update two different systems without a global transaction coordinator. Using two separate calls for the database and the message broker creates a window for partial failure, where data becomes permanently inconsistent. The transactional outbox pattern resolves this by persisting the event directly into the local database as part of the business transaction. By saving the message in a dedicated outbox table, you leverage the atomicity of the underlying database engine. An effective outbox table requires a unique message identifier, the aggregate identifier, the event type, and the event payload. Using a universally unique identifier for the message key enables downstream consumers to detect and ignore duplicate deliveries effectively. Store the event payload as a JavaScript object notation or binary column to maintain flexibility. This ensures the schema of the outbox table remains stable, even as the structure of your domain events evolve over time across different service versions.
A separate process called the message relay is responsible for reading entries from the outbox table and publishing them to the broker. This decoupling ensures that the application performance is not impacted by the latency or availability of the message broker. The simplest relay implementation is the polling publisher, which periodically queries the outbox table for unpublished rows. While easy to implement, frequent polling increases database load and introduces a latency delay equal to the polling interval. Transaction log tailing offers a high-performance alternative by reading the database write-ahead log directly. This method captures changes without adding query overhead to the database and provides the lowest possible latency for event propagation. Debezium is a popular open-source tool for change data capture that automates log tailing for various databases. It monitors the outbox table and streams every insert operation as a message to an Apache Kafka topic for downstream consumption. The outbox pattern guarantees at least once delivery because the relay only marks a message as sent after receiving an acknowledgement from the broker. This means messages might be sent twice if the relay crashes between the publish and the update step.
Since duplicate messages are possible, consumers must be idempotent to prevent side effects from repeating. Implement this by storing the processed message identifier in a local database table within the consumer service to track and skip already handled events. Maintaining the sequence of events is vital for domain consistency. Ensure the relay process preserves the order of the database transaction log so that a record updated twice is processed in the correct chronological order by all downstream listeners. Unmanaged outbox tables will grow indefinitely and degrade database performance. Implement a background task to delete or archive processed records after they have been successfully acknowledged by the message relay to keep the table size within operational limits. For PostgreSQL users, the listen and notify commands can trigger the relay immediately upon a commit. This approach combines the simplicity of polling with the responsiveness of log tailing without requiring complex change data capture infrastructure. The transactional outbox pattern is a fundamental building block for reliable microservices. It converts the unreliable dual write into a single atomic database operation, ensuring that your system remains consistent even in the face of network and infrastructure failures.